Hello everyone. In this video, we see how we perform the PCA and find out the principal component. So let's start. So here is the first question. Consider the following data set with the two features. So x1 and x2 are the features and these are the instance. And we perform the PCA and determine the principal components. So let's start to solve the question. So first we find out the mean. So we first find out the mean for the x1 and then we find out the mean for the x2. So mean of x1 is equal to 2 plus 3 plus 5 plus 6 divided by how many entities? 1, 2, 3, 4. So divided by 4. So this is equal to 4. So this is the mean of x1. Same we find out the mean of x2. So mean of x2 is equal to 4 plus 5 plus 7 plus 8. 4 plus 5 plus 7 plus 8 divided by 4 number of entities. So this is nothing but the 6. So again we draw one table where x1 is the feature, x2 is the feature. Now here x1 minus mean and here x2 minus mean. Now write all the entities as it is. 2, 3, 5, 6. This is the column for the x1 which we copied from here. Now this is the x2. So 4, 5, 7, 8. So 4, 5, 7, 8. Now x minus mean. So 2 minus x1 mean is 4. So 2 minus 4, 3 minus 4, 5 minus 4 and 6 minus 4. Right here. So 2 minus 4 is minus 2. 3 minus 4 is minus 1. 5 minus 4 is 1 and 2. Same here. x2 minus x2's mean. So this is the x2's mean 6. So 4 minus 6 minus 2. 5 minus 6 minus 1. 1 and 8 minus 6 2. So this is our first step. Step number 1. Now we find out the covariance, which is step number 2. Covariance matrix. So how exactly this covariance matrix? This is nothing but the x1 comma x1. This is the covariance. Now we solve this, but just a basic idea how exactly this matrix looks like. So this is like this. So x1 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 x2 x2 x1 x2 x2. This is same like the our simple matrix 1 1 1 2 2 1 2 2. Now we just find out the all the values. So here first we find out the covariance for the x1 x1. So covariance of x1 x1, which is nothing but the summation of this column. So summation of square of x minus x mean. So minus 2 square plus minus 1 square plus 1 square plus 2 square divided by n minus 1. So here total 4 entities. So 4 minus 1 3. So minus 2 square plus minus 1 square plus 1 square plus 2 square and divided by n minus 1 means 4 minus 1 3. So this is nothing but the 3.33 because 4 plus 1 5 plus 1 6, 6 plus 1 2 10, and 10 divided by 3 is 3.33. So this is the first entity of the matrix. Now same for our x2 x2. So this x2 same. First we take the summation of the squares of all the entities divided by n minus. So now covariance for x2. So this is again same. We put summation of -2 square plus -1 square plus 1 square plus 2 square divided by n minus 1. Now n is 4 for this example, -1. So this is again nothing but the 3.33. So now we find out the x1 and x2 but this x1 and x2 how we find out the covariance for this? So every time these two entities are the same for the covariance matrix. This x1 is equal to x2 and how we find out this? By taking the product. So summation of product of these two columns. So -2 into -2 plus -1 into -1 plus 1 into 1 plus 2 into 2 divided by n minus 1. So let's we find out this as well. So covariance of x1 x2, or let's say x2 x1, this is always equal. So -2 into -2 plus -1 into -1 plus 1 into 1 plus 2 into 2 divided by n minus 1. So 4 minus 1. So this -2 into -2 4 plus -1 into -1 1 plus 1 plus 2 divided by 3. So this is again nothing but the 3.33. This 2 into 2 is nothing but the 4. So sorry. So now 4 into 4 8 plus 2 10 divided by 3 3.33. So our covariance matrix is now this x1 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 x2 x2 x1 x2 x2 is nothing but the all the values we find out exactly equal, but every time it may become, it's not compulsory, it may be vary. Sometimes the values may be change, but in this case our all the values of the matrix are the equal. So put as it is 3.33 3.33 3.33 3.33. So this covar matrix. Now next third step, we find out the eigen value and eigenvector. So step number 3, calculate eigen value and vector. So for this the formula is mod of a minus lambda I is equal to 0. Now this A is nothing but the matrix, and which matrix? This covariance matrix. So mod of this A is our 3.33 3.33 3.33 3.33 minus lambda into I is nothing but identity matrix, and which is like this 0 1 0 1. This is the identity matrix equal to 0. Now multiply this lambda to whole matrix. So lambda into 1 lambda, lambda into 0 0, lambda into 0 0, lambda into 1 lambda, and this matrix as it is 3.33 3.33 3.33 minus lambda 0 0 lambda equal to 0. Now we perform the subtraction. So how we perform the subtraction of the two matrix? Each term we give particular that value, means this first term subtract by this particular first term, this minus this, this minus this, this minus this. So same we perform here. 3.33 minus lambda, 3.33 minus 0, 3.33, 3.33 minus 0, 3.33, 3.33 minus lambda as it is 3.33 minus lambda. So this is now new matrix equal to 0. Now simply solve the matrix. So how we solve the matrix? This term into this term minus this into this equal to 0. We find out the determinant, same like this. So 3.33 minus lambda into 3.33 minus lambda, 33 minus lambda, minus this is the one term minus 3.33 into 3.33, 3.33 into 3.33 is equal to 0. Now just solve the equation. So 3.33 into 3.33, 33 into 3.33. First we multiply these two, solve this two matrix. So first term into whole bracket, second term into whole bracket. So 3.33 into 3.33 minus 3.33 into lambda, this 3.33 into minus lambda means this. Again now minus lambda into 3.33 minus 3.33 lambda, and minus lambda into minus lambda plus lambda square, and this minus sign as it is, and this 3.33 into 3.33 is equal to 11.0889 is equal to 0. Now this is also 3.33 into 3.33. This is also 3.33 into 3.33. So simply we subtract, then it is also okay. But let's we perform one more step so you can you get the clear idea. So this term is nothing but the 11.0889, 3.33 into 3.33 minus, now this 3.33 lambda minus 3.33 lambda, may perform the addition here and make here minus sign. So this is 6.66 lambda, because minus addition plus we just add them and put here minus sign. Now lambda square minus 11.0889 equal to 0. Now this plus 11.0889 and this minus 11.000889 just cancel to each other. Plus minus get cancelled. Now just this small term minus 6.66 lambda plus lambda square is equal to 0. Now from this take put this lambda common, so lambda into minus 6.66 lambda. No, now here is no lambda because we put this lambda common by here, so only this integer plus lambda is equal to 0. Now this lambda is equal to 0. We separate the term. So lambda is equal to 0 and second term is minus 6.66 plus lambda is equal to 0. Only we separate these two terms. Lambda is equal to 0 and this whole bracket is equal to 0. So this is nothing but the lambda is equal to 6.66. This minus 6.66, when we transfer here at the right side, then this minus transfer into plus. So lambda is equal to 6.66. So now we have two values for the lambda. Lambda is equal to 0 and lambda is equal to 66. So we write here lambda is equal to 0 or lambda is equal to 6.66. Now next step is find out the eigenvector. These are the eigenvalues. Now for find out the eigenvector, same again formula is A minus lambda I into V. This second bracket is for the vector, this is for the value, is equal to 0. Now we find out this term. This term is nothing but this matrix. Only here previously we don't know about the lambda's value, but here when we solve the matrix, then we get the lambda's value. So just put here the lambda's value and the A is ready for the equation, because this matrix is also A minus lambda I and this is also A minus lambda I. So this equation we find out 3.33 minus lambda, 3.33, 3.33, 3.33 minus lambda into vector. Now how many rows are here? 2. So v1 vector, v2 vector is equal to 0. Now next we find out two values for the lambda. So which value we put here? So always select the value of the lambda which is the larger. So from the 0 and 6.66, this term is the larger, so we consider this greater value. So now we solve this. 3.33 minus 6.66, we put the value of lambda. This 3.33 as it is, 3.33 as it is, 3.33 minus 6.66 into v1 v2 is equal to 0. Now just simplify this. So what we get? 3.33, 3.33, because 3.33 minus 6.33 minus 3.33. Now this as it is, and this is also again 3.33 minus 6.66 is minus 3.33. v1 v2 is equal to 0. Now multiply these two matrix. So how we perform the multiplication here? First row, first column, second row, first column. Here only one column is present, that's why only small equation we get. But if two rows or two columns, if the matrix is big, then the multiplication is also increases, but this is the small one, so just we do only this. So first term of the first column, so minus 3.33 into v1 plus 3.33 into v2, first row, first column, minus 3.33 v1 plus 3.33 v2 is equal to 0. Second, 3.33 into v1 means second row, first column. So 3.33 v1 plus minus 3.33 V2 minus 3.33 V2 is equal to 0. Now we get two equations, first, second. So consider any one equation for the solving the further equations. So let's we consider this second equation for our simplicity, because here minus sign is present. So instead of this we consider this. So I put this second equation. So let consider the equation number second. If you put 1, then also the same values you get, but I start with the 2. If you want to start with equation number 1, then it's also correct. So my equation number 2 is 3.33 V1 plus 3.33 V2 is equal to 0. This is not plus, this is minus, because this plus minus minus. So minus 3.33. Now this whole term I transfer at the right side. So this minus get converted into the plus. So 3.33 V1 is equal to 3.33 V2. Now just transfer the vector one side and values one side. So V1 V2 divided by V2 is equal to 3.33 divided by 3.33. So this get cancelled to each other. So now just V1 by V2 is equal to 1 by 1, and this term you write in the form of the vector now. So this is now like this: V1 by V2 is equal to 1 1. This is the vector form. Same if you consider this equation number 2, I solve here, but no need to perform 2 times this step. Only consider any one equation and start to solve further. But for your understanding, I show you with the help of the equation number 1 also. So let's suppose someone start with equation number 1. Equation number 1. So how it is? 3.33 V1 plus 3.33 V2 is equal to 0. Then this minus term we transfer here at the right side. So this 3.33 V2 is equal to 3.33 V1. This minus term you transfer here. Now next we put all the vector one side and another integer at the one side. So 3.33 divided by 3.33, and this V2 we transfer here. So V1 by V2, same as it is, 1 by 1 is equal to V1 by V2. So again the vector is 1 by, is not the divide sign, only 1 1 is equal to V1 V2. So same values we get here. So I hope all you get the idea about this. Now next step, 5th, is normalization. So how we perform this? The x is equal to v divided by modulo of v. Now this v is nothing but the vector, and which vector? This vector. This is nothing but the v vector, because this is the vector, eigenvector, which we consider here. See, here we put v and then we put v1 v2, and now we find out the values of v1 v2. So again this is nothing but the our values of v. So here v is nothing but v1 v2 and the values are 1 1. Now the formula for find out the absolute of v is under root v1 square plus v2 square. So values of v1 is 1. So 1 square plus 1 square. This is nothing but under root of 2. 1 plus 1, 2. So how the equation is x is equal to v, and what is the value for v is 1 1. So we perform step by step so you get the idea. So this v divided by absolute of v is nothing but like this: v into 1 upon absolute of v. Yes, am I right? This is also v divided by absolute of v, and this is also v divided by absolute of v. Now just put the values. So v is 1 1 into this 1 divided by value of absolute v is root 2, which we find out here. So just I put the value of absolute v. Now multiply the whole matrix with this term. So 1 into 1 by root 2, 1 into 1 by root 2. So it is like this: 1 divided by root 2, 1 divided by root 2. So this is the value of x, means normalization. Now we want to find out the principal component, which mentioned in the question itself. So principal component is nothing but x transpose into x1k minus x1 bar, x2k minus x2 bar. Now we see what are these terms. So this x we find out here. So x transpose means this is the x, and if we want to find out x transpose, only this column shifted at the row. This first column means row x1, row x2 is just like 1 by root 2, 1 by root 2. We know how we transpose the matrix. Just transfer column into the row. So this first column we transferred into first row. So this is our x transpose, and this term xk minus x1, this is nothing but this term x minus mean, x2 minus mean. This is only changes its symbols, but meaning is the same. So first we consider this first row, first column, and then second column. So for our further simplicity, we put these values first. So 1 by root 2 is nothing but x transpose is equal to, if we find out the 1 by root 2, then we get the value 0.707 and 0.707. This is the x transpose. Now just put here one by one. So first we find out the PC1 for the first instance. This x transpose is nothing but my 7.707 0.7.7. This is also 0.707 this. And now this second matrix, this is we take from this. So for the first instance, my x1 minus mean is -2, and for the x2 is -2. So this -2 we take here in the second matrix, -2 -2. Same for the second instance, PC2. This x transpose as it is 0.707 into, now for the second instance is here -1 -1. So this is -1 -1. Now for the same PC3 0.707 into third instance So for that 1 1, and for the last 2 2. 1 1 and here 2 2 for the fourth instance. PC 4. This is the principal components. So 0.707, 0.707. Now just simplify the two matrix and get the answer. So how we simplify? First row, first column. So 0.707 into minus 2 plus 0.07 into minus 2. So this is nothing but the minus 1.414, and the second term is also minus 1.414. This 0.707 into minus 2 plus 0.707 into minus 2. We get minus 1.414 minus 1.414 is nothing but minus 2.828. Same for second, third and fourth instance. So now I show you one more example and then I directly write the values. So first row, first column means 0.707 into minus 1 plus 0.707 into minus 1 into minus 1. So minus 0.707 minus 707 is nothing but the minus 1.414. Same for here, first row, first column, first row, first column. So this minus, just we write plus, because here we multiply with minus ones, here we multiply with plus 1. So just this value is same, 1.414. Simplify. If any doubt, then let me know in the comment box. Same for 0.707 into 2, 0.707 into 2, and just add them. So we get 2.828. Now which value we consider for the principal component? So because here see the question, perform the PCA. So this is all the PCA which we perform, and determine the principal components. So if here no mention, find out, determine the 2 principal component, 3 principal component, then that particular values you put. And if just write here determine the principal component, then only one value if you suggest, then it is also okay. So from this, which value is the highest? This is the principal component for the question. So from this, minus 2.828, minus 1.414, 1.414 and 2.828, which value is the larger one? This 2.828. So our principal component is is equal to 2.828. If mentioned 2 principal component determine, then this 1.414 is also next greater value. If 3, then next greater value is this, and next greater value is this. So now only I suggest one principal component, which is 2.828. So this is the final principal component. So just we check which steps we follow. So first we find out the mean, then we subtract the mean from the each feature, then we find out the covariance matrix, then third what we do, we find out first eigenvalue means we find out the lambda, then we find out the vector means v, then just we normalize this, normalization means we find out the x, then we last find out the principal components PC. So these are the steps. So by following these steps, we perform the PCA and find out the principal component. So if now anyone has any doubt or any query, then let me know in the comment box. Thank you.